Hello everyone and welcome. This is Mark from ThinkLabs. Today I'm doing a screencast on automated deployments to AWS. Guess I start with a little introduction about myself. I am a certified AWS solution architect professional level. I work as independent consultant where in recent years I took on DevOps and SRE roles. I come from a technical testing background where I focused on performance testing and test automation. I did that for more than 10 years. Just to make sure all of the presented opinions are my own. To give you an even better idea about me, I thought it's best to quickly show you what I did for the past 1.5 years. I have worked on Glomex cloud deployment tools. The project started early 2016, where I joined the team a few months later. My part was to make the tool more robust and usable. It is clearly a team effort, as one can see from contributions. Adoption of the tool quickly went from one team to company-wide. In March 2017, Glomex won the Gartner Award for Best Infrastructure. Shortly after that, we open sourced the tool. Meanwhile, the company has restructured and many of the team members left. But the tool is open source, which allows us to continue to use and tweak it. We made a fork now. You can choose between the original version of the tool and the new and improved version. I want to give a brief overview of the presentation. I understand that you are coming from different backgrounds. Therefore, we begin with some context so everybody can make the most out of this talk. I introduce infrastructure as code and why I think this is the most important concept in today's IT, as important, for example, as continuous integration. I give an overview on the mechanics of an AWS deployment. Everybody loves code samples because code doesn't lie, so I walk you through a complete deployment using the tools. Then we wrap things up. Before we start, a little piece of advice. Some of you are different learning types. I, for example, like to structure things in T-shape, so I give a little bit of an overview and context before I go into all the details. So don't get lost in the big picture and stay on board. We are going to look into the details soon. Why are we here today? You need test environments, and as we all know, preparing test environments is a headache. I talk about automating AWS deployments. This is a good fit, don't you think? In this section I go through some concepts just so everybody is on the same page. You probably have seen that one on Twitter. SNAFU. The military came up with a term for that. Situation normal, all fucked up. It is human to get used to a bad situation and not to realize anymore that something is wrong. You all know this situation, ops problem or test problem now. The dev responsibility ends with code complete. Other people can deal with the remaining work. Sometimes this also implies less important people. Clearly, we have a cultural problem here. For us, this means we spend work with firefighting, with repetitive and boring work. I think it is very important for you to understand that you are not alone in this situation. This is very common. I talk to many people in the industry, and almost everybody reports similar issues. Many companies try out a DevOps revolution or DevOps transition. They want to get rid of the dev, ops and test silos, working together instead of finger pointing. What is the problem with this kind of transitions? Exactly, people. And transitions also take time. But why is this all necessary? This worked fine for a long time. I think to really understand what is going on, it is necessary to take a step back. For that, I want to introduce the bathtub curve. At the timeline on the left, we see the pre-industrial era. Markets of tailor-made solution. Next, the industrial era. Practically unlimited markets. As a business, I am limited only by my own capacity. I'm striving for cost efficiency and to scale production. Today, in the post-industrial era, we have global markets. Continuously respond to changing demands. Key drivers in the industrial era: efficiency and scale, and today in the post-industrial era, effectiveness and speed. I want to quickly present two things I found useful in dealing with this. The SRE book. SRE means keep the site up, whatever it takes. Reliability is the number one feature. It is about effectiveness, basically means do the right things. To summarize, applying software engineering to operations. Build an organization so people work together and to create incentives for this. People often claim, but we are not Google, this does not work for us. Well, I think Toyota Kata is the answer for that. This is a fantastic book. Over a decade of research went into that. Toyota Kata is a way of changing behavior, developing people, not just solving the problem. Establishing behaviors takes time, practice and coaching. This reduces risk by taking small steps. Everybody can do that. I think it needs management buy-in for lasting and company-wide effects. As you see, optimizing for change, effectiveness and speed has many organizational aspects. You need to address these or you will get stuck. Solving organizational aspects is not enough either. There are some technical aspects, enablers, and I'm going to talk about these. Metrics are important for you to keep on track. It is important to pick the right ones for your work. Some examples: percentage output spent on new features, time to get a simple change into production, the number of deployments in a given time, number of failed deployments in this time frame. Or you can mine the code repository for metrics, like, for example, find hotspots, code that is changed often, or temporal coupling. There's a fantastic talk by Adam Thornhill. He also wrote books about these topics. Is this a deployment? This shows a web developer who works on a bunch of JavaScript and CSS files. He pushes his code to Git, maybe some tests and approval steps, and the deployment is done, syncing the files to CDN, and the new application version is live. Of course, this is a deployment. I understand that many developers work like this, but I had a misunderstanding in the past, so I want to define what I mean when I say deployment. If I talk about a deployment, I talk about something else. A deployment for me looks like this. I have an NDA with my customers, so I cannot show any projects I'm working on. So I got one from the internet. This stack is the National Airspace System. I'm sure you agree with me that this looks more like what you typically find working at a telco, a bank, in retail, in media, etc. This diagram is about interfaces. Note that this has already been simplified. So this is not the reality, it's a model. When we look at it, we identify clusters of applications that are more tightly coupled, like comm systems, planning, HR, finance, logistics, etc. And each cluster basically talks to every other cluster. So when I talk about deployment, I talk about this kind of scenario. I want to quickly cover one more thing: AWS first strategy. According to Gartner's Magic Cloud Infrastructure Quadrant, AWS is both leader in innovation and execution. When I look at the revenue side of things, I don't think that this is going to change soon. The revenue of AWS is 10 times bigger than all the 14 competitors together. Revenue in 2016 was $12.2 billion US dollars. So what does AWS first mean? For example, we do not operate databases ourselves. Instead, we use managed services. By doing so, we benefit from efficiencies of scale and scope. Doing so allows us to focus on working on relevant business functionality. Now we get into the most important concept of this talk: Infrastructure as code. What is that? I have found a definition of the internet. I think it's from AWS. Infrastructure as code is a practice by where traditional infrastructure management techniques are supplemented and often replaced by using code-based tools and software development techniques. Well, that makes sense to me. Another definition by Stelligent: techniques, practices, and tools from software development applied to creating reusable, maintainable, extensible, and testable infrastructure. I think this definition is way more comprehensible. But wait. Applying tools and practices from software engineering to managing infrastructure. Now I get it. This definition is by ThoughtWorks. I love them for their help to sort through our industry's buzzword jungle. There's also a recording of a presentation by their boss, Martin Fowler. I'm a big fan. Most of the stuff he presents is fantastic. Or as Werner Vogels puts it, everything that used to be hardware is now software. For me, this man really is the transformer. Have you heard the phrase pets versus cattle? This is exactly what we are talking about. We need to change our thinking about how we manage infrastructure. What this really means is no more SSH login to the server to make changes on a command line. I think definition-wise, we are set up very well now. I hope this is helpful for you. Let's take a look at the workflow. Code documents our infrastructure. With this code, we are able to destroy a server and confidentially rebuild it. No snowflake servers anymore that nobody likes to touch. The code is pushed to version control. We can do rollbacks, look into changes, and pass configurations. We can do code reviews, etc. Now we can integrate. And like with our application code, we want to integrate often because small changes mean less risk, and deploy our infrastructure. To set up this workflow, we use the exact same tools we have in place for software development already. The beauty is we already know how to use them. Think continuous integration and continuous delivery pipelines for your infrastructure. Infrastructure as code allows you to set up a reliable workflow for our infrastructure. We automate so we can move faster and manage our infrastructure efficiently to accommodate change. We truly become cloud native so we can take full advantage of the cloud. We use AWS CloudFormation, so we let computers do the work of setting up servers and services. The CloudFormation service consists of 3 parts. The template, a JSON file that defines parameters and resources. The AWS managed service itself. It does things like stack creation and stack update. It detects errors and rolls back changes. The stack is what we want to build. AWS resources like, for example, EC2 instances, load balancers, databases, and all that jazz. Now we understand infrastructure as code and AWS CloudFormation. Can we do AWS deployments? For that, I think it's best to first get an idea what an AWS deployment comprises of. The next section covers the topic of AWS deployments. Finally, we are going to talk about AWS deployments. Let me quickly cover a few general aspects. First of all, let me point out that this is an area where matters get really individual. By that I mean that it is necessary to align your cloud infrastructure with your organization. Naturally, this means that your infrastructure as code depends on your organization's size, workflows, etc. But I observe some commonalities that I want to highlight here. AWS provides you with the AWS well-architected framework. This is a set of guidelines and best practices. I hope this is going to be interesting for you. If you already know all the ins and outs about the AWS well-architected framework, you have permission to doze off for a few moments now. Serious AWS customers, by that I mean companies that run their production system on AWS, usually utilize a multi-account infrastructure. My former boss wrote a blog post about the mechanics and details. I can recommend that to you. Multi-account infrastructure means a centralized account which contains an organization. This organization in turn contains multiple accounts. Billing in this scenario is usually consolidated into the central account. In this way you get the volume discounts from AWS. Besides that, the accounts of your organization are isolated from each other. With that, our intention is to minimize blast radius, to, for example, limit impact of attacks, human error, etc. Access to accounts is usually managed with IAM, Identity and Access Management. We have users, groups, roles. This means you log in to your central account where you have no permissions whatsoever. The only thing you can do is assume a role, which allows you to access resources at an account where you actually work. An actual productive AWS setup gets a little bit more involved. For example, you need to structure your account into compute centers called VPC and configure the analog to networks, firewalls, etc. But that would be enough material for a talk on its own. A few remarks on how to organize CloudFormation stacks. We see an account. The account contains a blue base stack sample and a green supercast sample stack, the one I am going to show you how to deploy. Stacks are deployed using Cloud Deploy. This is usually done by your CI tool, but can be done from the command line too. Why I show this slide to you is so you can see how to handle shared resources. The blue base stack contains shared resources that other stacks depend upon. For example, we use the S3 deployment bucket during code deploy. Code deploy creates a deployment artifact from your application and it uploads it to S3. Then the artifact is deployed onto the EC2 web server instances. We all love ChatOps, right? So we want to automatically create notifications in our Teams workspace tool. In this way, everybody gets informed about the status of our most recent deployments. Of course, the channel can be customized. Integration with the workspace tool is via its webhook. We do not want our infrastructure as code to contain any secrets. One way to solve this is to store parameters in the parameter store. We then use lookups to retrieve parameter values during deployment. According to your permissions, you can list, read, update values, or create and delete keys from the parameter store. For example, we store the ID of the base AMI, the image we use to launch new EC2 instances. We also store the webhook to integrate with our workspace tool. We love the parameter store, especially since it is free. But there are other solutions available, like for example CredStash. In the next section I'm going to walk you through a complete deployment where we are going to look up keys from the parameter store. Welcome to the practical part of this talk. Here we are going to deploy an application to AWS and you are finally going to see code samples. The supercar sample is a really simple web application. It consists of a simple JavaScript frontend, a RESTful web service backend, and for sake of simplicity, this application has no database. I want to walk you through some preconditions. Obviously, you need an AWS account. You have to have a role that allows you to deploy via CloudFormation. And you need to set up your local environment so that you can access AWS resources from remote. Usually this means you have a .aws credentials file that contains your AWS access key ID and AWS secret access key. Usually your user account is set up to use an MFA token. This is multi-factor authentication. And you need to have the Think base sample stack installed in your account. Now I switch to demo mode. I prepared a terminal to work in. So first we clone the repository of the sample application. So I already prepared the GitHub address from this sample repository, so I don't have to type it. Let's clone that. And I open this web console for other AWS. We don't need that for the deployment, but I want to use it to show you what's going on behind the scenes. So here I'm in the CloudFormation section, and you see what I referred to earlier as base stack for this account is already installed, and there is no supercar sample stack deployed. In the terminal, I go into the folder of my application. I have set up multiple credentials for different accounts, and I have a little plugin installed that allows me to switch into the right account. With that, we have set the scene for the deployment. Now I'll show you a little bit of code. So here, this is the sample stack, and here we have the configuration. So we can have for one stack we can have multiple different configuration to, for example, deploy the stack into different accounts or different configurations. So this is taking stuff out of the base stack via lookups. So it gets a DNS name, it gets an instance type T2 nano, and there's an auto-scaling group, and I don't really scale that up. It's just one instance. And it uses VPC. This is like a compute center. It looks up the default subnet, and this is all the parameters for the cloud section of the tool, and it gives the stack name. Here, think supercar sample stack. And the other tool we use is code. We define the bundling for the artifact, so it takes all this part of the application taken from the repository that I just checked out. It takes the code deploy where the stuff for the deployment is located, and the JavaScript application, the images, and the backend. So it bundles the artifact. And here we have the S3 deployment bucket that we talked earlier. And here the reference for the deployment group in the CloudFormation stack. So this is my configuration I use for the deployment. And I also have the CloudFormation stack itself. So I don't use poor JSON templates. So I use Troposphere. That gives me more flexibility and a more like verbose type of templates that is more like a programming style. Yeah, just initialize the template, give it a description. In the parameter section, I define the parameters that I used, like the VPC ID, the instance type, hosted zone, DNS name, auto-scaling, etc. All the parameters. And then I just go through in all the details what I need for the stack to deploy. So I don't want to really go into all of these details. So it's really well defined in AWS documentation or in the Troposphere documentation. What we are going to do is to go into a deployment, and for that I already showed you that the application is not deployed. Here in the terminal I change into the infrastructure folder, and I do a cloud deploy. What that does is it generates a JSON CloudFormation template, and it uploads the template to the CloudFormation service, and now is already the create stack is running here. We can look into that here in the AWS console. So here we get the same information like on the console, and we see the creation is in progress. So welcome back. It took about 2 minutes or so to set up the load balancer and the autoscaling group, and to launch the Linux instance and distribute the DNS record. So this always takes a little while. Here now the deployment is finished, and I go back to the AWS console, refresh, and as you can see, the stack is now completely deployed. Here I opened the ChatOps team workspace, and we get the message that the supercar sample stack was successfully deployed. So next step would be to actually deploy the application into the Linux instance, and for that I use the code deploy. Now what's happening, the tool creates an artifact that contains all the code and images for the application, and it zips up the artifact and uploads it to our S3 deployment bucket. And from this bucket, I can quickly show you the bucket. And this would be this one. And here we have our artifact that was just uploaded. Now our stack is deployed with code deploy, and the deployment actually is running. And so it already validated the service. So our application now is running in the stack, and here in our tool we see we got another deployment from code deploy, and it was our deployment group with this long name was successfully deployed. Now I can access the application and use it, and so I could change some values. Create new cars, etc. So the next step, I don't want to run the application indefinitely. I just want to take down the stack immediately, so to save costs. So welcome back. The delete command completed. So this was a successful delete. Here in our team workspace, we see the response. It was deleted completely, and also in our CloudFormation stack in the AWS console, we see that the stack is gone. So that's all from the demo. I guess that means back to slides. Let's wrap things up. We covered some topics like DevOps, transition, deployments, AWS first strategy, infrastructure as code, AWS deployments, and I showed you how all these things come together, walked you through a deployment of an application. So now we understand infrastructure as code, how to set up a workflow for our infrastructure, how to automate so we can move faster and manage our infrastructure efficiently to accommodate change. But is this the end of our journey? No. Now we mastered all of this, and we can start to make our infrastructure more intelligent. For example, make it scale intelligently, or build self-healing infrastructure. I want to invite you all to use the Think Cloud deployment tools and to give me feedback. Thank you. I made a list of resources I mentioned during the presentation for you. I guess that's all for today. Thank you. I hope the information is helpful to you and you enjoyed the presentation. I had tons of fun preparing the slides and recording the video. So I'm looking forward to see you all at the conference. Take care. Bye.